So here is an example of Canvas quiz statistics. So here you'll see the average score, a high score, low score, standard deviation, and the average time to submit. So this is an example exam with, I think it's randomized, so you're going to see different attempts for different questions. And then you see the distribution, the frequency distribution of scores. So you see that it's due to the numbers, you're seeing a relatively normal distribution, slightly skewed to the right, which is pretty common. Depending on how difficult the test is, you might see it severely skewed to the right. When you go to the question breakdown, you're going to see the number of attempts, you see the question stem, and you're going to see the answers and the distractors. So of course, in this example, the correct answer is marked in green and the check mark. The remaining, the distractors are in black or don't have a check mark. So that way you can actually see how many and to what degree, and what you want to see are that the distractors were equally attractive in that they all had answers. They weren't totally obvious in that one distractor got all of them and the other ones did not. That would mean possibly that the other distractors were not as, or they were overly obvious that they were wrong, which then makes your question much more easily answered correctly. If it changes the possibility from 25% to 50% that they can get it correct just by guessing between 2 versus 4, then that makes the question more difficult and less reliable. Here are just the percentage of students who answered it correctly. You want 60% or higher. If it's lower than 60%, then you've got a question, even if it has a good discrimination index, whether or not you have either not taught the material, was the question too tricky or too difficult, so that even if you had a good discrimination index, it was too picky in that only a few top students really got it, the rest didn't, but really it just wasn't a fair question. So again, the stats and the learning analytics only tell you so much, but they should be flags for you to then go back and talk with the SME, or if you are the teacher, to go back and reflect on the question quality, if the material was covered, and so forth. So how are these actually calculated? And what does discrimination index really mean? Well, the discrimination index is called the point by serial. So what I'm going to do is I'm going to take you into the Excel spreadsheet that has some of the data points and just explain to you how these point by serials are calculated. So this is actually some of the key data points that has gone into the visual that I just showed you. This is the visual. So it's got the question ID, that's just needed. A question title, that actually is the question stem. So the answered student count, that is how many students answered that question. Now you'll see that the numbers are all over the place. This is what you'll see if you have a randomized quiz or a randomized exam. So if you have 93 and 239, that's because 239 students were exposed to that question. Only 93 students were exposed to that question. So that is something to consider when you have a randomized exam. Now, one of the things that they do to discriminate for the discrimination index is the main purpose is for a good quality question, you want the question to discriminate between top students and low students. Essentially, you want the question to be able to determine who understands the material and who does not understand the material. You don't want the question to be as likely to get it correct or as likely to assess understanding as it would be if you just if it was just random. So you want it to be able to discriminate. Now, we're not talking about the type of discrimination, meaning prejudice. We're talking about discrimination, meaning telling the difference between and identifying differences. So in order to do that, you need to take the students, and what they're going to do is according to the entire exam, they're going to break the students up into 3 groups. You're going to have the top student count, the middle student count, and the bottom student count. So the bottom student count is going to be about 27.5% of your students. The middle student count is going to be about 45% of your students, and the top student count is going to be about 27.5% of your students. So what you want to see in a good question is that the bottom students mainly get it wrong and the top students mainly get it right. It's not that we want people to get it incorrectly. It's that what we're looking for is that we don't want top students to get it wrong and bottom students to get it right. That's when you're going to see a negative discrimination index or a negative point by serial. Because essentially what the discrimination index or the point by serial is it's a correlation between how well you scored on the exam and how well you scored on that question, and how good of a predictor it is for your student success. And so if you got that question wrong, what's the correlation for you also doing poorly on that exam? So the point by serial is just another iteration of the Pearson correlation coefficient. So quiz question count is just the total number of questions that are in the quiz bank. Not, since it's randomized, it's not the total number of questions that was exposed to the students. It was only 50 questions were exposed to the students, but there was 95 in the bank. So the correct student count. So this is asking, of the 239 students who were exposed to this question, how many students got it correctly? There was 195 students who got this question correct. How many students got it wrong? Well, again, it's 44, but if you took 239 minus 195, you'll also get 44. So these two numbers, the correct and the incorrect, add up to the total students who were exposed to the question. This is the same numbers, but in proportion. So it adds up to 100% of the students who were exposed. So if you were to take 195 divided by 239, you're going to get 81, which means of the students who were exposed to the question, approximately 82% got it correct, and approximately 18% got it wrong. And that's where this number comes from. Okay? Now we start to get into some interesting data leading to this point by serial. Now we say, okay, of the top students that were identified here, how many of them got it correct? 67. So you have 67. So 100% of the top students got this question correct. Of the middle students who perform moderately, probably a C, how many got this correct? 94 out of 109. Okay, so it's a little bit less. Of the bottom student count, that was 63. How many got this correct? 34, only 50%. So what you're seeing is you're seeing 100% to maybe a little bit less, probably 90%, down to 50%. You're seeing fewer and fewer students getting it correct, which is what you should see. That's a sign of a good question. Now, of course, it could be that you have students, everyone gets the question correct. At that point, you need to ask yourself, is the question too easy, or is it just something that was taught very well and you want to make sure that everyone got it? again, it's something that the statistics cannot tell you. Variance is just the average. It's basically the difference, how much the scores vary. So if you have numbers or scores all over the place, you're going to see a larger variance versus a lower variance. So difficulty index, you'll notice that the difficulty index is the same as the correct student ratio. Alpha, we're not going to get into this now, but it's basically stands for Cronbach's alpha. It's a number that represents the degree and the quality of the overall assessment. Is it a good, solid assessment? Is it assessing what it should be assessing? Again, it has to do with some of these numbers that we've got going on over here. In general, if it's a really, really good exam, you want to see 0.8, 0.9. We've got 0.59. That's actually not bad. It could be better. I've seen 0.07 before. Now we've got the point by serial. So what you want to see is you want to be looking at 0.25 or higher. If it's less than that, so if you go over here, so this was green and black, that meant it's good. Red means, check it out. Now again, if you have a really high number of students who answer this correctly, your discrimination index is going to be lower because it's not discriminating between those who understand and those who do not understand, because there's a large proportion of students who do not do well in the overall exam who are getting it correct. That may be okay, but you're not going to get a good discrimination index. So it's up to you to determine whether or not the question is good or not. If your quiz is full of questions that everyone gets 100%, then either it's too easy, or maybe the purpose is just to get students to practice, and it's not necessarily to discriminate between those who understand and those who do not. So again, you as an instructional designer or teacher need to understand the purpose of the question and the exam when interpreting the learning analytics. So what in this example Canvas has done for you is gone through and calculated all of this for you. But now you know what goes into that number, at least a little bit. So essentially, this is telling you, how well does this discriminate? Are the students who do well in the exam getting it correct? Let me see if I can find one that's negative. I may not be able to find one because this was a pretty good exam. That one was pretty good. Essentially what you're going to see, I'll just fudge in some numbers here. What you're going to see if you got a negative point by serial is that it's actually reversed. So correct top student count is you're going to have a very low ratio. Let's say you have only 30 of them getting it correct. And then the correct middle student count would be, let's say, maybe 50. And the correct bottom student count, maybe it's 50 there too. And so that would be a lot of bottom students got it correct. Or maybe it's just random all across the board. But when it goes up, then you know something's a little bit up. Maybe it's tricky. Maybe it's just people are randomly guessing. So the proportion and the pattern is off. So it's going to alert you to that. So this is a very, very handy tool that is available to you in many learning management systems for you to go through and assess and evaluate your instruction, your curriculum, and the quality of your assessments.